Now that we know what the solutions to these differential equations looks like when they have complex eigenvalues, let's do an example. So here is my matrix in normal form. And I need to start by finding the determinant of A minus Ri. So I'm going to subtract R from the diagonals. -1 minus R, 2, -1, and -3 minus R. When we multiply this, we have -1 minus R times -3 minus R, minus multiplying the other way, 2 times -1. When we multiply this out, we would get 3 plus 4R plus R squared plus 2, or R squared plus 4R plus 5. And we want to know when this is equal to 0. You can try to factor, but this in fact will not factor. So instead, we're going to use the quadratic formula. We have -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplifying this, I would have -4 plus or minus the square root of -4 over 2. The square root of -4 is 2i, so I have -4 plus or minus 2i over 2. And simplifying this gives me -2 plus or minus I. Now that I have my eigenvalues, let's look at my eigenvectors. And like I said in the previous video, we're really only concerning with the positive one of these, the one that says plus I, so -2 plus I. The matrix that we were considering before said -1 minus R, 2, -1, and -3 minus R. Sticking this value in, I'm going to have -1 minus -2 plus I, 2, -1, and -3 minus -2 plus I. As I simplify this, I end up with 1 minus I, 2, -1, and -1 minus I. And we want to know when I can multiply this by u1, u2, and still get 0, 0. As I multiply out my first row, I have 1 minus I times u1, plus 2 times u2 equal to 0. My second row gives me -u1 plus -1 minus I times u2 equal to 0. Before, when we got these two equations, we always had an infinite number of solutions. They were really the same equation written two different ways. And that's always going to be the case. So I need to solve one of these for u1. And instead of dividing by imaginary numbers, I'm just going to default to the second one. In this case, I can add u1 to both sides. And I get this, -1 minus I u2 equal to u1. So when I try to find my vector u, I'm going to pick a number for u2, like 1. So u1 would be -1 minus I times u2, or -1 minus I. And we're going to write this in two different pieces, the -1 and the 1, and then the pieces with the i's. This has a -I, this has a 0. And then we're going to break it up once more. -1 I, -1 1. Now I'm going to factor out the I and get -1 0. This vector right here is my A vector, And this vector right here is my b vector for my solution. We also had that r was equal to 2 plus I in this case, so alpha is the 2 part and beta is the coefficient of the I, the 1. Now that I have this, I can start writing out my solution, which said C1 e to the alpha t times cosine beta t times a, so negative 1, 1, minus sine beta t times b, which is negative 1, 0, plus c2 e to the alpha 2, so c2 e to the 2t, times sine beta t, since beta is 1, I have sine of t, times a, plus cosine beta t times b, negative 1, 0. And let's try to simplify this a little bit. So I'm going to try to write each of these parentheses as a single vector. This is cosine t times negative 1, so negative cosine t. Negative sine t times negative 1 is plus sine t. My second row, cosine t times 1 is cosine t. And then negative sine t times 0 is 0. And then I'm going to write plus c2 e to the 2t times, my first row gives me sine t times negative 1, so minus sine t. Cosine t times negative 1 would be negative cosine t. The second row, sine t times 1 is sine of t. And then cosine of t times 0 is 0. So I finally have my solution. And let's see if we can go a little bit further. Let's suppose that we know if t is equal to 0, then x is equal to 1 and y is equal to 0. This tells me that the first row should be equal to 1 when t is 0. If t is 0, e to the 0 is 1, so this becomes c1 times cosine of 0 is 1, so this is negative 1. And then sine of 0 is 0, plus c2 times 1. Negative sine of 0 is 0, negative cosine of 0 is negative 1. So in other words, 1 is equal to minus c1 minus c2. The second row should be equal to 0 since y is equal to 0. Well, I know that cosine of 0 is 1, so this is 1c1. And I know that sine of 0 is 0, so this is c2 times 0, or just 0. So in this case, I know what c1 is, so I can easily find c2. c2 would be equal to negative 1. So now I can actually formally write down my solution fully. C1 is 0, so this whole piece right here is going to go away since anything times 0 is 0. I then have minus C2 is negative 1, so negative e to the 2t times minus sine t minus cosine t. And then the second row would be sine t. And this is my final solution.